Hello everyone. Our today's topic for A-level chemistry is Group 2 elements. Group 2 elements are normally called alkaline earth metals. Why these are called alkaline earth metals? Because majority of their compounds are obtained from the earth crust and the nature of their compound is basic, mostly basic. That's why these are called as alkaline earth metals. Group 2 elements contain beryllium, magnesium, calcium, strontium, barium and radium. Now, proton number of beryllium is 4, of magnesium is 12, of calcium is 20, strontium 38, 56 and 88. What is the difference pattern? The difference pattern is there is difference of 8 in first two elements, then difference of 8 is again between next two elements, then there is a difference of 18 between these two elements, difference of 18 between these two elements and difference of 32 between barium and radium is there. On the basis of this formula we can easily evaluate the proton number of the elements starting from the first one. Now, with these proton numbers, these are the electronic configuration of beryllium 1s2, 2s2. In case of magnesium, 1s2, 2s2, 2p6 and 3s2. Now, electronic configuration of all these elements, calcium, strontium, barium and radium, this shows that the last electron of these elements enter into s orbital. S orbital. In case of beryllium, last s orbital is 2s. In case of magnesium, 3s. Calcium, 4s. Strontium, 5s. Barium, 6s. And for radium, it is 7s. This is the electronic configuration of these elements, and this indicates as the last electron entered into s orbital, so these are also called as s block element in the periodic table. S block elements in the periodic table. Now, beryllium is second period element, magnesium is third period element, calcium is fourth, strontium is fifth, barium is sixth and radium is seventh period elements. Now, as we know that the period number is indicated by number of shells. Period number means the number of shells. If we represent these numbers with respect to number of shells, it means that we can show beryllium just like this. We can show magnesium just like this. We can show calcium just like this. It is quite clear from this trend that radium will have 7 total number of shells in an atom. Now, this trend is indicating that from top to bottom, the size of an atom is increasing. The total distance from nucleus to last shell electron is called radius of an atom, because atom is considered to be spherical. So, this maximum distance from nucleus to the last shell will represent the radius. It means that from top to bottom, radius of an atom is increasing. size of an atom is increasing because the number of shells is increasing by passing through each period. Whenever this distance will increase from the nucleus to the last shell electrons, automatically the hold of the nucleus on the outermost shell electron will become weak, and this weakness also increased by the electron present underlying shells. These underlying shells electrons, while revolving, interrupt the force of attraction of the nucleus on the last shell electron, and this interruption of these underlying electrons by decreasing the force of attraction between nucleus and outermost shell electron, this is called as a shielding effect. It means that as the number of shells are increasing from top to bottom, it means that the shielding effect is increasing. So the force of attraction of the nucleus of the last shell is decreasing, and due to this reason, from top to bottom, number one, ionization energy decreases. Second, melting point decreases. Why? Whenever the two atoms come closer to each other, definitely if larger atoms come closer to each other, then the total distance between their nuclei will be larger, and due to larger distance the force of attraction will be less. Less force of attraction will broken easily by applying small force of attraction. That's why melting point will decrease automatically. The melting point decreases from top to bottom. But on the other hand, as the distance between the nucleus and outermost shell electron is increasing, and due to the shielding effect, hold of the nucleus on outermost shell electron is decreasing, so the removal of electron from the last shell become easy. So according to the chemistry language, the electron gained, lost or shared for the completion of the last shell of an atom is called chemical reaction. It means that if this calcium atom lose electron easily as compared to beryllium, we can say that calcium is more reactive than beryllium. This also trend indicates that reactivity of elements increases down the group. Reactivity increases down the group and melting point decreases down the group because size of an atom is increasing and force of attraction between the atoms is becoming less. So lesser energy will be required to melt them. All these are present in the solid state. On applying energy, we can melt them quite easily. Now, if we compare from top to bottom, beryllium to radium, as I have already explained that the loss of electron by the larger size atom is becoming easier. It means that we can say reactivity from top to bottom is increasing. Due to this reason, this barium normally become much more reactive. That's why this is placed in oil to keep itself intact. Otherwise, in open air, barium can react with air or with moisture. So, to save barium, its reactivity increases too much. It becomes reactive just like alkali metals. That's why, like alkali metals, to save the barium, we keep barium metal into oil to keep it out of contact from air or moisture. This is the reactive. Now, Normally, radium is a radioactive element. Radioactive elements are those substances which emit radiations alpha, beta, gamma rays, and they convert into another new elements immediately. That's why under the normal conditions of temperature and pressure, and normally the compounds of the radium are not present. That's why radium is not discussed normally, and chemical reactions of radium are not available. These are the preliminary all information. Number one, atomic size of the elements of group 2 elements increases down the group. Radius increases as they lose 2 electrons from the last s subshell. That's why all of them get a positive 2 charge. This is their valency and this is their oxidation state, and this oxidation state is fixed. This is not changed. It means that from top to bottom, number of shells increases. From top to bottom, shielding effect increases. From top to bottom, reactivity increases. It means that all these are the trends which are associated with their number of shells and the size of an atom. The application of group 2 elements are too much. 3 of the elements, calcium, strontium and barium, they produce colored flame. Calcium produces brick red flame. Strontium gives scarlet or bright red flame, while barium produces apple green flame. Due to their different colors, all these elements, calcium, strontium and barium, they are used in flares or in fireworks. In the fireworks, these are used too much. Magnesium burns in air with a bright luminous flame, and it produces a bright light which can be used for a longer time to locate the area. This powdered magnesium, due to its much faster reaction, this can also be used in the fighter jets which emit magnesium in form of flares that can mislead the infrared detection system of missile. So the magnesium powder is also used in this purpose, just to mislead the missile targeting. Now, all of these elements reacts burn with flame, as we have discussed that the reaction of beryllium is very slow. Beryllium on heating, beryllium only react on heating with oxygen, and this heating might be till 1000 degrees centigrade temperature, and then it produces beryllium oxide. But from magnesium, whenever we supply too much heat, then magnesium burn in oxygen, producing magnesium oxide, and this burn with a very bright flame. Similarly, all these elements show the same chemical reaction, producing the respective oxide: calcium oxide, strontium oxide, then barium oxide. Now, if we compare all these oxides, it means that size of atom of the alkali metal is going on increasing. If size is increasing, then the last shell subshell S electrons are released easily. It means that the metallic character from top to bottom increases considerably. If metallic character increases, it means that due to the smaller size, beryllium oxide is not too much ionic. It will show some little bit sorts of covalent character also. But as from top to bottom, size of cation will increase, then the ionic character of their oxide will also be increased. It means that as compared to magnesium oxide, the beryllium oxide will show more ionic character. It means the shifting of two electrons from beryllium atom to oxygen atom is very easy as compared to the shifting of two electrons from magnesium to oxygen. It means that all these oxides, whenever these are added into water, they produce oxide ion and then metal cation. Now, as I have explained, in comparison, beryllium oxide will show more ionic character. It means it will produce more oxide ion. If magnesium and oxide ion are produced, and if barium positive 2 plus oxide ion are there, if we have added into water, this will be ionized more as compared to this. What will happen? Now, this oxide ion will combine with water, producing hydroxide ion. It means that in case of barium oxide, if more oxide ion are there, these will react with more water molecule, producing more hydroxide ion. As compared to magnesium oxide, it means that the basic character of the beryllium oxide in aqueous solution will be much more as compared to magnesium oxide. In other words, we can say that from top to bottom, these oxides of two metals becoming more and more basic or alkaline in nature. Means if they are producing more hydroxide ion, automatically their solubility is also increasing, producing more hydroxide ion, due to which we can say that the nature of group 2 metal oxides is becoming more alkaline from top to bottom. And similarly, we can also say that solubility of the group 2 metal oxide is increasing from top to bottom. This trend is also quite visible. Now, if we consider these two graphs, if we consider the melting point of these elements, first of all, remember, the melting point of beryllium is maximum. Why? Because size of beryllium is very small. Whenever two atoms will come close to each other, distance between two nuclei will be less. All the nuclei will apply force of attraction on electrons. They will have more force of attraction, means more higher melting point. That's why the melting point of beryllium is approximate 2000 degrees centigrade. 2000 degrees centigrade. Now, after beryllium, what happens? The difference of proton becomes 8. It means that in case of magnesium there are 12 protons present in the nucleus. But side by side, what has happened? One extra electron containing 8 electrons comes in between nucleus and outermost shell electron. In case of beryllium, there are only 4 protons present. In case of beryllium, only 4 protons are present and second shell contain 2s electrons. That's why the force of attraction, due to the lesser shielding effect, force of attraction of nucleus on the outermost shell electron is much more strong. That's why the melting point is very high. What happens into magnesium? No doubt the number of protons is increased. It becomes 12. But side by side, what happens? One shell containing 8 electrons is also involved and the shielding effect is increased considerably. We can say as compared to increase of proton into the nucleus, the shielding effect and the distance between the nucleus and outermost shell electron in case of magnesium is increased more as compared to the increased number of proton. That's why the force of attraction of the nucleus to the outermost shell electron decreases rapidly, which is reflected here. The melting point of the magnesium drops significantly. Now, what happened next? From magnesium to calcium, again 8 proton is increased. 8 proton is increased, but now 1 shell is increased. Now, that as compared to the distance increased from the nucleus to the outermost shell electron, the number of proton in the nucleus increases very much and their effect become more significant. So, nucleus force of attraction on the outermost shell electron increases. That's why the melting point of calcium increase as compared to magnesium. But from this, it is quite clear as the number of protons are also increasing, but now the shielding effect is becoming dominant. So the increased number of proton in the nucleus is becoming useless. So the distance between nucleus and outermost shell electron is increasing, shielding effect is increasing. That's why the melting point of strontium and barium decreases gradually. In this manner, all these elements behave. Now, if we discuss the density, what happens? What happens in case of beryllium? The density is little bit high. Density is a little bit high. Why density is a little bit high? Because the size is very small. In the fixed volume, larger number of atoms will can occupy. That's why the density is high. In case of magnesium, as size is increased, so the density is decreasing little bit. And in case of calcium, due to the increase in size, also density is decreasing. But what happened in case of strontium and barium? In case of strontium and barium, along with the number of protons, the number of neutrons also increases too much. That's why their molar masses increases. As the molar mass increase, the effect comes and the density of both these elements increase as compared to the first 3 members of second group. Dear students, I have explained all the concepts regarding group 2 elements and some of their chemical reaction and their solubility. Please comment, share, like or subscribe my YouTube channel to get the more available videos which are going to be formulated during this time. I thank you all.